Hello everyone. So today we are moving on to our next section, which is on our next conic section. Hello everyone. So let's have our next. Hello everyone. So our next conic section, we're almost there, approaching to our last conic section today. So technically we're going back to 8-1, which is our first conic section, and this is about parabolas. As you guys already know, parabola looks like a U-shaped graph, which comes from a quadratic function. That's what we know so far. But there are a few other details we should know, actually. We needed to know about parabola. So that's what we're going to do in this section. What are those details? So let's look that up. So first thing, when I say parabola, what's true about this? So let's just start off with kind of like definition of this. So about this parabola, what's true? So basically this parabola is set of points. So means on this graph there are multiple numbers. So all of these numbers, what's true about all these numbers on the graph? So basically parabola is a set of points. And what's true about those points? All of those points are equidistant from two different things. Equidistant from a point, which is called focus. And at the same time, it's equidistant from a line. Which is called directrix. So that's something new for you guys. Oh, I spelled it wrong. Just always. Okay, so directrix. So if I draw this parabola again, let me show you what I'm talking about. So let's say if this is a parabola here. So if I pick any point on this graph, let's say this point is on here. Then what's true about that point? Then this point will be same distance from a point which is inside the parabola. Let's just say that focus point is here. This is called focus. So the point here will be same distance from this point, and then at the same time it would be same distance from a line that's outside the parabola. So distance over here and here would be the same. You can pick any point on the problem no matter where. So that point always going to be same distance from two different things. Focus, which is inside, directrix, which is outside. I know it doesn't look like the same, but once you're going to see on a graph or exactly kind of like, or even graphing calculator, you'll see that it definitely looks the same. But this is just not because of it's not drawn to scale, so that's the reason it looks a little different. So I just talked about two different things. I said focus, which is a point, and that point always gonna be inside the parabola. So it could be anywhere in the graph, all right? And the other thing I just talked about was directrix. And directrix is a line which is always going to be outside the parabola, all right? So special things about focus and directrix. I repeat, any point on the parabola would be same distance from focus and directrix. Or let me just show you this example. That's going to be something easy to understand. So let's say if I pick this vertex, so that vertex, since that's one of the point on the parabola, so it's going to be same distance from this point, which is focus, and it's same distance from the line, which is the directrix, isn't it? Now it does look the same. So anyways, so few other things you needed to know. So what I'm going to do is I'm just going to draw 4 different boxes because we have 4 different type of problems to talk about. As you guys may know, normal parabola is something going up like this. That's the normal one. That's the one we always deal with, right? That's not the only one. There's another one actually, facing down. That's what you guys might have learned in previous math courses. But now we have 2 more. So the one that goes right side, the last one is the one that goes left side. Okay, now let's talk about details about all four graphs. As you guys know about the first one, if the parabola faces upward, so you know it's going to be x squared equation with leading coefficient, a positive leading coefficient. So I'm just going to say a is bigger than 0 or it's positive. If parabola faces downward, so still it's going to be x squared equation, but the coefficient of this term would be negative, means a would be less than 0. What about parabolas going right and left? What about those? So something that goes to the right, and now this is where variable is going to switch. So this is now y is equal to x squared equation. Instead, it's going to be x is equal to y squared equation, just because it's going sideways. And since it goes to right side, so a would be positive. So a is bigger than 0. Going to the left, so it's going to be y is equal to, oh my bad, it's x is equal to y squared equation, just because it's going to left side. It's negative a, or I could say a is less than 0. That's what I have so far. Now let's talk about focus and directrix. So if I look at the first one, so focus, as we know, it's going to be inside and the line would be outside. So that's how the graph's going to look like. If it's something like this, it's down here and the line would be up here. Third one, here and line outside. Focus here, line would be outside. Now let's label each one. So since focus, normally we put letter C for foci. So I'm just going to say C here. How would you label these? And let's label that. So for the focus point, I would say it's 0 and 3. Oh, not 3, my bad, it's C. And the line, which is outside, it's a horizontal line, so you know it's going to be y is equal to, but isn't it same distance, but it's opposite and it's outside? Isn't it, it's going to be opposite of the number you have for focus? So this is going to be negative c. Same thing down for the second one. For focus, it's going to be 0 and negative c. And for the directrix, it's going to be y is equal to positive c. I hope by now, I guess you should learn the pattern. So the focus and the directrix always opposite, right? Unless the center point is different. So keep in mind. Okay, this one, so the focus would be c comma 0. And the directrix, since it's a vertical line, so it's going to be x is equal to negative c. For the fourth one, which is the last one, focus would be negative c comma 0 and x is equal to positive c. Okay, so make sure you have this information handy all the time, because these four graphs we need all the time in order to understand the equation, okay? And the last thing we needed to know, so this a in all of these equations, how do we find the a value in the equation? So this is the equation you needed to know. A is equal to 1 over 4 times p. What's that p in this equation? So basically this p is the distance of focus from the vertex of the parabola. So distance from, so like let's say if I take this focus, how far this point is from the vertex. Or you can even look at from the other side. Since it's the same distance, it's not going to make any difference. So you can say directrix to vertex. What is the distance? So distance from focus, or you can say the directrix. How far the vertex is from focus or directrix in the problem, okay? So let me show you an example. And okay, so today's lesson is for parabola with having vertex at 0, 0. Tomorrow I'll show you with h and k, like different vertex for that parabola. So how to deal with those problems? So let's look at first example. Okay, so you need to write an equation. So that's my question. And keep in mind, visualizing those points would help you a lot. So please take few seconds and draw a rough sketch just to get a better idea about the equation and the graph, okay? So the first one, if I say the vertex is at 0, 0, so the vertex, which is h and k, is at 0, 0. That's the first thing I know. And the focus is at negative 3, 0. Okay. First thing, what I'm gonna do, just to get an idea, I'm just gonna plot this. Okay, so because I have 4 different graphs, it would help. This would help actually. Focus is -3, 0, 1, 2, 3. This is the focus point. So if focus point is here, -3, 0. So, and the vertex is here. So by looking at these 2 points, can we figure out what direction this parabola is going to go or open? So for sure, just because I know parabola goes inside, so I know my parabola is going to go this way. Okay, so if focus is inside, so you know the line definitely would be outside at the same distance. Since this is -3, this is how far this vertex is. So you know the line would be outside at the same distance. So if this is -3, this is going to be +3 outside. That's not all. We still have to find the equation. Trying to go slow. So since the parabola opens left, so you know this equation is x is equal to y square equation. You could always refer to these 4 graphs. Okay, please have it handy. Since it's going to left side, so a needs to be negative. I would say I'm almost like 80% done with this problem. Okay, almost there. Now the only thing that's missing in this equation is this a value. I would keep the negative there. Why? Because I know this negative tells me the direction. Okay, so the only thing I have to solve for is a. A is 1/4 times p. What is the distance? How far this focus is from the vertex point? So the distance is 3 units. So I would plug this in. 1/4 times 3, which is 1/12. So the a value would be 1/12. So I would keep the negative again. So you just have to look at the distance. And you know, distance always going to be in positive number. 1/12, y to the second, and I'm done. And one more thing. Actually, I've noticed in your textbook, they actually simplified this equation like one step after this. You know what they did? So they actually multiplied both sides by -12. So on the back of the book, you'll see your answer as -12x is equal to y to the second. So don't get confused if you see something like this. You don't have to do it. Normally, I would prefer keeping it like this. It's easier. Okay, especially when you work backwards, which is going to be in next few examples. Okay, I have one more, actually 2 more. So let's say I have vertex at 0, 0. Directrix. This time it's the directrix, which is the line. Directrix is y is equal to -5. Okay, now let's plot it first. So vertex is at 0, 0. Directrix, and it's y, so it's going to be a horizontal line. It's at -5. By looking at this line, can we figure out what direction the parabola is going to open? For sure. Yeah, parabola is going to be facing up. Okay, go back to those 4 different graphs. So what do you think? What kind of equation would match up with this? It's going to be y is equal to x squared with a positive. So how do we find a? A is equal to 1/4 times p. So what's the distance? How far this line is from vertex? It's 5 units. Again, we are not looking at the negative or positive. It's just the distance, which is absolute value. So solve, it's going to be 1/20 x squared, and here you go. Last example. Okay, now this is where we're going to work backwards. So we already know our equation. Oh, remember I told you your textbook is giving you weird type of equation, kind of extra step simplifying. So let me show you. This is how you'll see the equation in your textbook. Okay, first thing, I would make it into the form we normally see our equation. So first thing, I would divide this by -12. So my equation is y is equal to, x is equal to 1/12 y to the second. Okay, now let's try visualizing it. This is negative a value and it's y squared. So if it's negative a value with y squared, you know it's the sideways parabola. Since it's negative, so it's going to go this way. Focus would be here, directrix would be here. We need to solve for focus and directrix. Okay, now this is the part where you see the distance. And normally it's 1 over 4 times something, right? And you already know it's 12. So 4 times what gives you 12? So it's 3. So you know this is going to be -3. This is going to be at 3. That was pretty quick, right? Because we already know the number and you already know the pattern. Some people can't do mental math. Or for a problem like this, let me show you. Let's say instead of 12, if it's different number, like something which is not, that doesn't click, so like click like the last one. So let's hit 7 here. Do you think you could finish it really quick? See, some people can't do it. So for some people, those who really want to follow the steps, what I would do is, I'm going to show you that a kind of solid way to solve for that. Normally, our equation is A is equal to 1 over 4 times P. Normally, we solve for A, but this time, A is already there, which is 1/7. Keep in mind that negative just tells you the direction. Don't use that for any of the equations, okay? Now, we are solving for P, so let's just do cross product. 4P is equal to 7. What's P equal to? 7/4. So 7/4 is going to be, since we use a different number, this one. So I would say it's -7/4 here. X is equal to +7/4 here. So that's just another way to do it. Again, mental math. If you think you could do it, go for it. If not, then that could be just another way. Okay, so yeah, this is all for today. Thank you for watching. Bye-bye, guys.